on. S squared plus t squared equals r squared, and m squared plus n squared equals o squared. Thank you. I know I gave out more than one. Thank you. All right. Of course, the m and the n do not have to be in any particular order. Do I really need to go over this page? I don't think I do. Let's just do a couple. If you got the couple that I did right, you got the test, or you got the rest of them right. Because if you can do it once, you can do it every time. 34. Check your work. Number 8 should be a 34. Number 11 should be 8.7. And number 16 36.7. Is everybody okay with Pythagoras? Excellent. That's just a regular triangle. Now we got some real problems to do. 12-foot ladder leaning against the wall. The ladder's 12. It's 3 feet from the wall. How far up there? That is a subtraction. $11.6. Yeah? Oh, okay. Oh, by the way, guys, my ladies and gentlemen, my wife did respond. She's very impressed with you. Let's do this one. Find x to the nearest tenth. So this has to be 10. So this has to be 144 minus 100 square root 144 plus 244. 15.6. This one is This one is 3.8. Is that right? Let me check. It's 9.8. No, I lied. 7.4. 7.7. All right, so everybody's good with Pythagoras? I only did a sampling of them because, again, if you can do Pythagoras, you should be able to do Pythagoras. Yeah? All right. Let us move on then, cabbages, to page 53. Now, before I go any further, I need a moment here. A couple of things need to change on page 53. This dot by C needs to move up one spot, so it's actually by the letter. If everyone could do that, that would be nice. And I need everybody to answer this question for me. How many of you, again, are coming from the 9th grade? You just did grade 9. Did your teacher do any trigonometry with you? Okay, so grade 9s, what you are about to see is brand spanking new. You have never seen it before. You will want to pay attention. Grade 10s, I knew there would be a bunch of grade 9s in here, so I have to do the trigonometry as if no one has seen it before. So I'm going to start with tangent. Grade 9s, you don't know what I'm speaking of right now, but grade 10s do. the first thing I give you, you could do all the work much easier if you use sine and cosine. But the grade 9s need the practice of learning tangent. So the first bit is going to be really, really a pain for you because you're going to want to use sine and cosine. Do not. Everybody understand? Follow along with me because everybody needs the practice. If you didn't need the practice, you wouldn't be here. You'd be out kicking ass in summer, right? Okay, so we're not going to use a ruler. We're just going to draw it by hand. But everybody draw all of these line segments. I'm going to use different colors to do it. B to F is right there, and A to F is right there, right? Then I'm going to use blue for C to G, and I'm going to use blue for A to G. Now, obviously, the blue goes with the red. It goes all the way along, yes? And then I'm going to use green for D to H, and G to H, and I'm going to remember that the green goes all the way along. Is everybody cool with that? Everyone good? All right. What did I make here? I made a right angle. What did I make here? A right angle. What did I make here? A right angle. Yes? Now, I'm going to connect A all the way up to D. Now what have I made? How many? 3 right angle triangles, yes? Plus the giant one, right? 1, 2, 3. Everybody cool? All right, now, what do you notice about those triangles? There's a right angle in every one of them, yes? This angle right here is in every one of them, isn't it? Which means the right angles are all the same, this angle are all the same, which must mean these angles are all the same, yes? Everybody follows my logic there, right? Now, if all the angles are the same, we just proved 40 minutes ago that if all the angles are the same, we can do this fraction stuff, can't we? All right. So that applies to here. So right now this is written as a ratio, BF to AF. Yeah? BF to AF written this way is a ratio. The other way we write ratios is a fraction, yes? So B to F is how long? 3. A to F is how long? 4. So this is 3 over 4, which is 0.75 degree, or 0.75, right? Everybody cool with that? Okay. What's A to G? Well, if you count it, that's 12. And C to G is 9, which, guess what, is 0.75. And then the last one is 15 over 20, which again is 0.75. Now, what do you notice? This angle that I am highlighting, which is angle A, is in all 3 triangles, isn't it? It's in the red one, it's in the blue one, it's in the green one. The angle hasn't changed, but the size of the triangle has changed. Does everyone see that? Most importantly, grade 9s. Do you all see that? Okay. What does that mean? Well, that means that regardless of length of the legs, the ratio between them stays the same. Now, what does that mean for us? Well, if this line down here, which I'm going to highlight in blue, if I drew that line all the way over to Harsharan, and I drew this line that I am highlighting in green all the way back to Sophia, and I measured it, and I measured not the green line, and I drew the line from Harsharan back to Sophia. If I made it that big, and I compared the fraction, what decimal would I get? 0.75, no matter what. Is everybody cool with that? What if I drew this blue line all the way to Mission, and then I turned 90 degrees and walked down the road in Mission? What would the comparison of them be? 0.75. What if I drew this line all the way to the moon, and I drew this line, I turned 90 degrees at the moon and followed this line, and I compared them? What would it be? 0.75. Because no matter what the size of the triangle is, this angle stays the same. Does everybody understand that? Especially grade 9s. Yeah? Okay, good. This ratio is called the tangent ratio, and we nickname it tan. It is on your calculator. You've seen the buttons before, sin, cos, and tan. Well, now you're going to actually use them. Tan. And it is true for all right angle triangles. If you've got a right angle triangle, this rule holds true, no matter what size it is. Does everybody understand? Okay. Now, grade 9s especially, this angle got me this comparison, right? 3/4. What if I changed it and I put letter H? No, I've already come up to H. Letter I right there. And I drew a new triangle. What would that, and I'm going to erase everything else. So I've got a new triangle now. What would the ratio be for that triangle, which is a different angle? How far up did I go? 1, 2, 3, 4, 5. How far this way? 12, 13, 14. So this angle would be 5/14 because I changed the angle, not the lengths of the sides. Is everybody cool, especially grade 9s? Yeah? Okay. Now we are going to do some calculator work. Everybody needs to have their calculator in front of them. If you are using your phone, you need your calculator, your phone in the mode that shows the buttons sine, cos, and tan. If you're using an iPhone, you will need to turn it sideways so you get the more buttons. You need to see the following buttons on your calculator if you are still using your phone. That is the first thing you need to do. Can everybody see those buttons on whatever machine they are going to be using to calculate? Everybody can? Good. Now, look at your calculator screen. You should see either a D or the abbreviated word DEG somewhere on your screen, unless you have one of these super fancy calculators like I have. If you have a super fancy calculator like this, I need you to push the math button. No, I lie. The mode button. And when you push the mode button, you need the word degree to be highlighted. So use the arrow keys to go down and highlight degree and push enter. So degree is highlighted. Is there anybody in the room that does not have a D or an R or a D or a DEG on their screen? Anyone? What? Do you have an iPhone? Turn it sideways. Sine, cos, tan. Oh, you don't have the DEG. We'll fix that in a minute. So yours says rad. Now it says day. You have a G. So you need to push. Worst calculator to change this on. I can't remember how to do it. Anybody else? This guy. You got a D. It's right there. No problem. Anybody else? Okay. If you're not sure, you're about to find out. Now, listen to me, please, and listen carefully. This is a very difficult unit for teachers to teach because all of you have different calculators. Every single one of you, look at your machine right now and push the button that says tan. If your calculator does what mine does and writes the word tan on the screen, then there's a proper name for it, but what I like to call it is a forward calculator. And this means you punch in what you see. So everybody, if the word tan comes up on your calculator to do this question, you are going to push tan 35. And you will probably need to push equals, but not necessarily. Everybody do so now. And your calculator should show... I have tan twice. Yes, thank you. Your calculator should show 0.70207. Okay? 0.700. 3 decimals is more than enough for trig. Now, listen to me closely. Is there anyone in the room who is using a calculator that does not put the word tan on the screen? A phone calculator will not. You have a backwards calculator, so you must press 35 tan, and you will not have to hit equals. But your calculator will show you 0.700. Can everybody make their calculator show them 0.700? Everyone. Get your calculator. It doesn't say DEG. Remember how I walked around and asked if everybody's calculator said DEG? And I said it like 17 times. I got up and I walked all the way around. And I helped a bunch of people. You sat there with your thumb in your bum. Don't waste my time. I'm not talking for the fun of it. You hit that DRG button until it says DEG. Everybody good? Now, listen to me closely. Do the next two the way your machine requires you to do it. So either tan 15 equals or 15 tan. And tell me what decimals you get. What is the tan of 15? .268. Perfect. 0.268. And what is the tan of 45? 1. Now this should tell you that depending on what degree your angle is, that will change your ratio, which we already knew from here, correct? When we had the line going way up there, it was 0.75. Well, now the line is way smaller, so the decimal will be smaller. Does everyone understand that? Especially grade 9s. Okay, good. Okay, now, look here. Do I have an equals or a degree anywhere here? No, I've been given the decimal. My calculator, gentlemen, shut up. Is that clear enough for you? This is the second time in 4 days I've had to talk to the three of you. I don't want you here if you aren't going to work, because that is a pain in my ass. Leave if you do not want to work. If you want to talk to each other and giggle like 5-year-olds, then go away. Is that clear? Because I don't know how to make it clearer. Here I do not have a degree, do I? In the previous questions, I had a degree, didn't I? And my calculator was able to give me the decimal. Well, now I have the decimal. I don't know the degree. So if you look closely at your calculator, there's the button tan, and then printed right on the calculator, right above it, is tan -1. Tan finds the ratio. Tan -1 finds the angle. And we use the same method, except to get to tan -1, we have to hit second or shift, whichever is on your machine. So if you have a forward calculator here, you are going to hit shift, tan, 0.75 equals. If you have a backwards calculator, you are going to hit 0.75, shift, tan. And that will give you the angle. Everybody try it. For me, it is second, tan, 0.75. Now, 0.75 was the decimal we had at the very beginning, right? So when I hit equals here, that is going to tell me what this angle is, all the way up to our original angle, right here. Everybody cool? What is it? 36.86. Now, angles, believe it or not, none of you know this, or I bet most of you don't know this. We don't measure angles in decimals. We measure angles in minutes and seconds, like time. So, because that's how we officially do it, whenever you are finding me an angle, unless I specifically ask you, I want you to round your angles to the nearest whole degree. So what would this be? 36.86. We would round it off to 37. Is that cool? Okay. Now, this is negative. I don't want it to be negative. So we're just going to erase that. Because that requires a whole offshoot from the lesson that we don't have time for in summer school. So everybody tell me, what is this angle? Which will be shift, tan. Now, people, I don't want to write shift tan anymore. I want to write tan -1. Yeah. I know, I just did a whole big thing about that. I just explained that. I don't want it to say negative. I want it to be positive. Because if it says negative, then I got to go off and teach you a whole bunch of other stuff that in the regular school year I have time for, but now I do not. So everybody just make it positive. And what is the answer? Tan 51 degrees. Excellent. And what is the last one? Shift tan of 2.5 gets me what? 68. Excellent. Can everybody find the decimals and the angles, especially grade 9s? Excellent. Okay. So, for any angle, now when I say for any angle, I mean not the right angle. This only works for the other two angles, not the 90. For any specific angle in a right triangle, the tangent ratio compares the opposite. What does opposite mean? Opposite side, which means across, to what we call the adjacent side. So the opposite means across, and the adjacent means beside. Now, I'm going to do a visual demonstration, and this is more important for the grade 9s again than the grade 9s and the grade 10s. Right now, who is the student that you would say is opposite to me? Maybe you don't know his name, but who would he be? Zach, or Erlen, or Isha, or Prusha. Does everyone agree? Because they are across the room from me. Yes? Now, who is a person that is adjacent to me? Vikram or Sevak? Is everybody cool? Does everybody understand? All right. Whose point of view was that question from? Mine or yours? Mine. Everybody agree? So when I am here, they're opposite, they're adjacent. Yes? Am I in a new spot? Which means, are my opposites and adjacents going to change? Yes. Does everybody understand that? Your opposites and your adjacents are from where you are. Now, obviously, I am not a little tiny man inside this triangle, am I? No, I am a short, fat man outside here yelling at you. Yes? So you have to imagine, when you were doing trig, that you are in one of these corners because it is from your point of view. Does everybody understand? Good. Let's try that. Find the tangent ratio of angle A. Where is angle A? Is it on the top, on the left, or on the right? It is on the top because it is labeled with a capital letter A, yes? So I want the tan of A. And I remember that tan is the opposite over the adjacent, yes? So if I want angle A, here is where I am. Right? So this is the point of view that I'm approaching this question from. What is opposite to me? I go across and I hit 12. So 12 is the opposite. What is adjacent to me? Now this is tricky because there are two lines that are beside me. But one of those lines already has a special name. Which? The hypotenuse already has a special name. So that guy doesn't get another special name. So the adjacent is beside, but it's not the hypotenuse. All right? So what number do I see beside me? 5. So opposite over adjacent is 12 over 5. Everybody cool? So now I'm going to go for a slide. But I only brought my face. I left my head up there. Now I'm down here. Am I in a new spot?
Yes.
Has my point of view changed?
Yes.
What is opposite to me now? So the tan of B, not the tab of B, the tan of B equals 5 over what? 12. I don't know why the numbers are disappearing. Is everybody good? Everyone. You understand that the opposite and the adjacent change depending on which corner of the triangle you are at. Everybody gets that. Sweet! Now, I want to know what those angles are. I have ratios, don't I? We know our calculator can tell us what the angles are if we have a decimal, yes? But we don't have a decimal right now. What do we have? Fractions. How do I turn a fraction to a decimal? You divide. So, how will I turn 12 over 5 to an angle? Well, I know I need to shift tan A, don't I? So if I have a forward calculator, I know that A is 12 over 5, correct? So how would I punch that into my calculator? Shift tan, bracket, 12 divided by 5, close brackets, equals. If I have a backwards calculator, I reverse that. Bracket, 12 divided by 5, close brackets, shift tan. What is the answer?
67.
Shift, tan, bracket. Oh, my calculator puts a bracket there for me already. Close brackets equals 67 degrees. Can everybody do it? Great. Now do it for B and tell me how big B is. What is B? What's B? 23 degrees. Is everybody cool? Now listen to me carefully. Write down what you had to hit to find these answers on your machine. What did you personally punch in? I have to push the following buttons. Second, tan. I get my first bracket, so I then push 1, 2, divided by 5, close bracket equals. That is what I push. You will probably push something different. Write it out. Everybody got it? Everybody's at the same spot now, yes? All right. Now, I want to show you something that we use in math that not a lot of people use anymore. At least I don't think so. I always do because I know that later in math you're going to be using this. So I'm going to show it to you now. The earlier you see it, the more practice you get with it. This symbol, some of you in grade 10 will have seen it, some of you won't. It's like an O with a line through the middle of it. It's a Greek letter. It is the Greek letter theta. Theta is the letter we use when we are dealing with an angle. Any angle. Doesn't matter what it is. If we are going to work with it, we call it theta. Everybody cool? So in this question up here, tan -1 of A, I would have written tan -1 of theta equals 67. Is everybody good? All it means is the angle that we are going to be working with. So, look at this question here, number 4, ABC, and it says, find the missing length or angle. Since we're going to be working with an angle, we are going to have a theta, yes? Now, theta is where we decide on our opposites and adjacents. It is our starting point, our point of view. Okay? So, in this case, theta is right here. This is the angle that we are working with. Do we have a value for it? No, so we write it as x. Now, once we have established this is the angle that we are working with, this is where we are looking from. So what is that? Opposite, adjacent, or hypotenuse? And I would prefer it if a grade 9 would answer, if that's okay, grade 10s, because I know you've seen it. What is that, Zach? Opposite. So my opposite equals 23. Everybody cool? What is that side? That is adjacent, and that equals 15. Now, since I have both numbers and I'm missing the angle, missing angle, is that tan or shift tan to find an angle? Shift tan. So I go to my calculator and I do shift tan, bracket, exactly what I did up here. Whatever you need to do, whatever you wrote here, you are punching into your calculator right now. But are you using 12 and 5? No. What are you using? 23 over 15. If you write it out, is it possible to do it wrong? It actually tells you what to do, doesn't it? It says shift tan 23 divided by 15. Can it be any easier? The writing on the page tells you what to do. What is the angle? 57? I will choose to believe you, because my calculator, I have a different calculator, it's taking me slightly longer to get to where I need to be. It is indeed 57. Is everybody cool? Everyone's good? All right. Look at the next one. Do I have an angle that I care about? Do I have an angle with which I am working? 15, correct? So if that's the angle that I'm working with, what is theta? Remember, theta is the angle that I'm dealing with. So what is theta here? 15. Once I have established that this is my 15, this is my theta, then now I know where my opposites and adjacents are, don't I? What is that? Opposite or adjacent? Opposite. So my opposite is what value? X. What is the 37? That is adjacent. That equals 37. Now I know that I already have my angle now, don't I? So I have a missing side now. Is that tan or shift tan for a missing side? Tan, because shift tan was the missing angle. And I do the same thing. Tan, I know my angle this time, so what do I write here? Instead of theta, what do I write? 15 equals O. What is opposite? What value is that? X over what? 37. Oh my God, is this an equation? Is there a letter in it? So what's my job? Isolate the letter. How would I get rid of divided by 37? Multiply. 37 times tan 15 equals X. So what's the answer? This is why we reviewed algebra at the end of yesterday. See? Punch it into your calculator, exactly what you see. 37, when there's no sign, what math is it? Multiply. So 37 times tan 15. And what do you get? What do you get? 9.91, right? One decimal place at least. 9.9. Everybody cool? Everybody cool? Okay, you try this last one. Remember, if you write it out, you can't do it wrong. See you.
How do you know what you're going to start with? What side? Like when you start the angle that you had figured out your...
So the diagram tells me what theta is because it gave me an angle. Right? Whatever angle I'm working with, that's where I start from. So that tells me my opposites and my adjacents. Okay? Now, if this was this, I'm going to just erase the 15. If this was 75, which is what it would be if this was 15, now I've got my theta becomes 75, and my opposite and adjacent change places. Got it? Awesome. So you guys try this one. Do you have a theta? What is it? 70. Once you've set up there, now, just as we talked about with CL, I now know my opposites and adjacents. What would you call the 14? Opposite, 14. And what would you call the x? Adjacent is x. Then I just set it up. Tan of theta. What's theta?
7.
So I like to write it this way right now. Tan theta equals O over A. So do I know theta? Oh, it's 70. Tan 70 equals O. What's O? Okay, it's 14. Over A. What's A? Oh, that's X. Now this is what we talked about last day. When the number's on the bottom, we multiply. The letter's on the bottom, so what do we do? Divide. This is 14 divided by tan 70. Everybody try that on your calculator and tell me what X is. And I guarantee that some people with a backwards calculator are going to get this question wrong. Is there anybody rocking the backwards calculator right now? See, Liz, what's your answer?
I don't have my... I did the other questions because there's no tan minus 1.
Yeah, there is. You just need to push second or shift. It's on there somewhere. Okay. What's the answer here? 5.1. Can everybody work with tan? Everybody. And when I say everybody, the 3 times I've said everybody is directly aimed at the grade 9s, because all the grade 10s should have seen this before. Are we good? Erlen. Did you do 37 times tan 15 equals? Bring it here. Because you have a backwards calculator, Erlen. So you have to reverse it. 37 times 15 tan equals. If you don't push equals, your calculator will not give you an answer. Everybody good? Everybody? All right. Turn the page over. This one's tricky. We've got 2 missing sides now. So work with your neighbor right now and see if you can figure this out. Do you have a theta? Can you do tan? And what finds the third side of a triangle? Go. Is there anybody that feels irretrievably stuck? Like you have no idea what to do? 1 is fine. All right. Everybody's had a bit of time. I want to make sure you're on the right track. You'll have lots of time to practice. Do I have a theta in this triangle? Do I have an angle that I care about?
Yes.
What is it? 30. Once I've set 30 as my point of view, there I am. What is opposite? X. What is adjacent? 24. Can I now use my formula? I have a theta and I have one of the other ones. Tan, what's theta? 30 equals O. What's O? X over what's adjacent? 24. Number on the bottom. Is this times or division? Multiplication. 24 tan 30 equals X. How do I punch that into my calculator? I know how I do it. You have to know how you do it. What is it? X equals 13.9. Was everyone able to get it? Everyone? Okay. Once you have X equals 13.9, what does that tell you? What does that symbol in a triangle mean? It's a right angle triangle. What works with every right angle triangle? Pythagoras. Pythagoras says that 13.9 squared plus 24 squared, if I square root that, what will I get? Y. This can be done in one step if you're good with your calculator. If you're not, take a second step. Do 13.9 squared plus 24 squared equals, and then square root the answer. I'm going to do it all in one step. And what do you get? $27.7. Now, before you handed this in on a test, you would check that it made sense. Is my hypotenuse the longest side?
Yes.
Yes. 30 degrees. That's not very far this way, is it? Which means I didn't go up very far there. So this and this should be pretty close in value, shouldn't they? Are they? Yes. Would this be okay to hand in? Of course it is, because we did notes on it. So we know this is right, yes? But in a couple of minutes, you're going to be doing assignments on this, and those are the types of questions that you should be asking yourself before you carry on. Everybody good? Now, I want you guys to notice a couple of other things that will help you here. If this is 30 and this is 90, what's this? Has to be 60, doesn't it? Because the angles in a triangle have to add up to 180, correct? So this must be 60. Now, notice the pattern. What is the smallest angle? 30. It's opposite 13.9. What is the smallest side? 13.9. Please notice that the smallest side matches the smallest angle. 60 is the middle angle, yes? It is across from the middle side. 90 is the biggest angle, isn't it? And it is across from the biggest side. It is another tool you can use to check that you have done your work correctly. Does everybody understand? Now, would you base what I just told you on the drawing or on the numbers? On the numbers. Because the drawings are not real, right? If I have to draw a right angle triangle that's lying flat on the ground, like across a river or something, it's tough to sometimes make it actually look like a right angle. So don't be fooled by the drawing. Is everybody good? Excellent. Here are 3 to try on your own with your neighbors. Remember, if you write it out, it's really difficult to do it wrong. Okay, ladies and gentlemen, I'm going to turn off the screen. I'm going to fill it all in while you're practicing it right now. Then I'll turn it on and we'll talk about it. Okay? Go. Of course, the screen is still recording, so you will see what I am writing if you watch the video later. All right? There are 4 answers. How many people have all 4? Because there's an X and a Y and then an X. How many people have all 4 ready to go? I only ask because I'm going to put it on the screen in a second. I want to make sure everybody's had a chance to try it all. Everybody's tried? The answers are highlighted in blue. 35 degrees, X is 12.1, Y is 14, and X is 1.8. Could everybody do it? If you can't, do not feel bad. Trig, is a little bit difficult because it requires you, the math isn't because your calculator does all the work, but it requires you to think about this triangle and where you would be in it if you were able to stand in it. Is everyone okay? Everyone is good? Everyone got these numbers? You might have a slightly different number for y. If you rounded to 12.1, you might have 13.97, which would be 14. Is everybody okay? Now, I would just like to say that is approximately the 150th time in this lesson I have said, is everybody okay, correct? And in those 150 times, has anybody asked a question? No. So what is the only thing I can assume right now? That everybody understands everything. Which means, when I say go on to the real work, should any hands go up? No, because you all get it. 1 second before you start on your own. What do the words on page 56 say? Angles in the real world. All of the work we've been doing has not been in the real world, has it? It's been on a piece of paper. And a piece of paper has how many dimensions? 2, right? Length and width. I can go in only 2 directions on a piece of paper. A piece of paper is like an Etch-a-Sketch, right? I can only go in 2 directions. Yeah? Is it possible for me to draw on a piece of paper, actually draw going up? No, because the piece of paper is flat on the ground. I can't draw a line this way, can I? If I draw that, we assume it to mean up. But it doesn't really, does it? Okay. So in the real world, trig applies. Let me give you an example. This building. Do you think they built this building full-sized, then took it apart, and then brought it here and put it back together? Of course not. That would be idiotic. How did they build this building? How do they build any building? What do you start with? A blueprint, a plan. Is the blueprint the size of this building? No. Is the blueprint 3-dimensional? No. So all this work to build this from a piece of paper this big is all done with trig. The trig is easy. It's opposite over adjacent. No problem. Calculator does all the work. But you have to be able to take that knowledge from 2 dimensions and move it into 3 dimensions. Everybody cool? And there's 2 ways that this happens. The first way that happens is up and down. All right? So, here am I. Right? That looks... Glasses. Brown eyes. Big smile. Sticky out tongue. And gray hair. Everybody cool? I am the point of view. It is from my point of view. Right? Because I am the one doing the measuring here. Is everybody cool? Right now, there is nothing. Is there anything on the page for me to look at? No. So my eyes are looking straight forward. Assume that is perfectly flat. That is horizontal. Have I made an angle yet? No, I have no angle yet because I only have one line, don't I? Everybody with me? Okay. I hear a plane. Where do planes live? Up in the sky. Here's my plane. Everybody cool? I'm a human. Every human, when they hear a plane going over, does what? Looks up. You all do it. Every one of you does it. And every one of you says for just one little second in your mind, I wish I was on that plane. No matter where you are. Unless, of course, you're already away somewhere. You've flown there and you've just landed. You're like, yes, I'm in Timbuktu. And then a plane goes over. You're like, I don't want to go home yet. Right? But you still look up at that plane, don't you? Yeah, you do. Lies. You look up at planes. Sometimes girls don't look up at planes. I'll give you that. All right. So, where will my eyes go? They started horizontal. Now I hear the plane. Where do they go? They go up to look at the plane. Now, have I made an angle? Yes. This is what we call an angle of elevation or an angle of inclination. Because my eyes went up in the real world. Everybody got it? So right now I'm looking straight at Sandeep. My eyes are flat. Zach throws a big old spitball and it hits up on the wall up there. And it makes a schlup sound. Where do my eyes go? Up to the schlup sound. I have now made an angle of elevation. Does everyone understand? Your eyes start flat. Look at my eyes. We're flat right now, yes? I know it's creepy. Just work with me. Look in my eyes. Keep looking at them. Keep looking. 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 Are your eyes up now? Where did they start? Down here. Since they went up, it made an angle of elevation. Understand? Everybody good? Okay. Now that's the easy one. For some reason, everybody understands that. Now, draw me again, or you, I don't care how you do it. There we go. Here I am. I'm up on a diving board. Okay? There's nothing for me to see, so where do my eyes go? Straight out here, along the horizontal, yes? Everyone agree? Son of a bee. See you in a few moments. I'm on the diving board, yes? All right. I hear the changing room door open and close, and somebody walks out of it. Right now, I'm the only person at the pool. As soon as somebody else arrives, what will my eyes do? I will look down and see them. So here is the other person. My eyes look down to them. Here's the pool. Have I made an angle? Yes, it is right here. It is going from the flat to down. This is what we call an angle of depression or an angle of declination. Now, here is where you guys are going to screw this up. In this triangle, you are going to say that this person on the ground here, they have walked out of the changing room, yes? Where are their eyes? They're flat out this way, correct? Until they notice somebody's on the diving board. Where do they go? Up to the diving board, creating an angle of elevation. The mistake that kids make is you call this the angle of depression. It is not. because it is not between the horizontal and where your eyes ended up. Does everybody understand? Now, the smart people amongst you will notice something. If my angle of depression goes down here, and this person's angle of inclination goes up there, and our eyes meet, what do you know about these two angles? They're the same. Okay? My angle of depression to somebody on the ground is the same as their angle of elevation. Everybody cool? That's a real world situation. Everybody good? All right. The other spot in the real world that we use angles is in orienteering or maps and directions. Yes? And that sadly has two different ways it can be done. They both start with north, east, south, west. Never eat soggy wieners. Or never eat shredded wheat. Or never, I don't know, there's a million of them. Now they're weird, okay? There's two ways to do it. In way one, north equals 0. And you go this way. East is 90 degrees. What then is south? 180 degrees. What then is west? 270 degrees. And what then is north? We're back to 360. Does everybody understand? It goes in a circle. So you've all seen this in the movies. Where's the camp? Oh, it's 60 kilometers on a heading of 82 degrees. Everybody has heard that in movies, right? Okay. You start north is 0, and then everything around. So if I asked you to draw a line at 82 degrees, where would you draw it? Don't actually draw it unless you're 100% sure. Where do you think you would draw it? Would you draw it in 1, 2, 3, or 4? It would be in 1. And it would be 82 degrees away from 0. Right? Which would be almost down to 90. That's where the 82 degrees is. Is everybody cool? Everybody good? So if I asked you to go for a 5-kilometer walk on a heading of 192 degrees, which would you be walking in? 1, 2, 3, or 4? 3. 192 degrees, which is just a little past south, right? So down there. Now, this is 192 degrees, correct? But I can't do trig with that, can I? Because trig only works with 90. But if I make this triangle, how far was this? 180. How far is this last little bit? 12. So now I have a triangle that I could do trig with, couldn't I? Because I told you to go for a 5K walk. So how long is this? 5. Now I could do trig. Does everybody understand? It goes 0 to 360 clockwise. Is everybody good? Yeah? Okay. These are one way we measure directions. The other way we measure directions are like this. You get a direction, you get an adjustment, and then you get another direction. So it looks like this. East, 40, north. This is your start. This is your amount of adjustment. And this is the direction of adjustment. All right? Is everybody cool? I haven't shown you what it means yet, but everybody understands this, yes? So if I told you to do this, you would start, if none of this was here, you would start walking east. But I don't want you walking east. I want you walking 40 degrees north from east. Everybody got it? I'm going to show you what it means right now. So I'm going to tell you, I want you to walk south, 30 west. Where would that line be? In 1, 2, 3, or 4? Talk to your neighbor, see if you can figure it out. It will be in 3. Because I started south, but I didn't really walk south, did I? I walked 30 degrees to the west of south. So I walked down here. How big is this angle right here? 30. And does that make a triangle I could do trig with? Yes, because this would be 90. Is everybody cool? Okay, let's do another one just to make sure. Then I'm going to shut up and let you work. If I told you to walk west 15 north, where would that line be? 1, 2, 3, or 4? It would be in 4. Because I would start west, but I would adjust 15 degrees to the north. Making this triangle, this is 15, and now I can do trig. Is everybody with me? That's the real world applications of trigonometry outside of blueprints and things. Everybody good? Remember, one goes from 0 to 360. The other way never goes bigger than 90, right? You just have to know the directions, west, north, south, all that. Now on a piece of paper, north is always what direction? Up. South is always what direction? East is always what direction? Right? And west is always what direction? Left. Everybody cool? All right. So, I want you on page 57. You are going to work on page 57 right now. Now, this is the first one of these you've seen. Please notice I have given you the answers like a textbook. If you're smart, you'll cover them and do the work. Then check them. That's why the answer in the back of the textbook. For you to do all the work and then check. Not go, I don't know how to do it. Oh, there's the answer. How do I do it? Try it first. Then check your answers check your work with the answers. Is everybody good? It is 12:25. I cannot stress this enough. A bunch of you are going to take this time and not do this practice. The answer right there, you're going to say, oh, I know how to do it. It's no problem. And yet, I just gave you a test that the majority of the class needed more than the amount of time I left for them. Right? And that is because you weren't really ready for it. So when I give you time to get ready for it, what should you be doing? Getting ready for it. Got it? Now, in a perfect world, I would be able to stop you in about 20 minutes. Say, is everybody good? Got all these questions right? You would all say yes, and I'd go on and teach one more little lesson. And maybe in that 20 minutes, I get your tests marked, and we go over that before the end of the day. Because right now, we've done tan. In a perfect world, I would like to get at least to number 4, but I'll recognize it if we don't. It's cool if we don't. But we do have an hour left. It shouldn't be a problem. You guys should take 15, 20 minutes for this. I'll mark your tests. If I get them done, I get them done. If I don't, wait a little longer. Do one more lesson. Give you a little more work. Maybe at the end of the day, I'll have the tests marked. Everybody go? Go. So, the tangent ratio works all the time. But tan only uses O and A, correct? Right? Is there a third side to the triangle? Yeah, there is. So, there are two others that work with the hypotenuse. The first one of them is the sine ratio. Remember, the angles are never the 90. The sine ratio, sine, on your calculator it's sin, equals opposite. We already know what that means, over the hypotenuse. And we already know what that means. The cosine, cos, equals adjacent. Over hypotenuse. And this sets up this fake word that every math teacher forever has been using. SOHCAHTOA. It means nothing. It's just an acronym of all three kinds of trigonometric ratios. Sine, opposite, hypotenuse. Cos, adjacent, hypotenuse. Tan, opposite, and adjacent. Now, down here, I want you to draw two triangles. Nope, that was a stupid way to do it. Draw them exactly the same way and label them as A, B, and C. Everybody cool? Everyone's got this? These are supposed to be exactly the same triangles, okay? So, over here with A, in A, what would be the sine of A? Now, what should this side be named? What do we name sides with? Big or littles? Littles. So this would be lil A, right? What would the hypotenuse be? Lil B. I've done that on purpose to get you away from always saying C is the hypotenuse. What would this side be? Lil C. Then this one's going to be the same way. A, lil B, C. Right? Okay. Looking in this triangle, on the left, what is the sine of A? Sine is opposite over hypotenuse. So what is opposite to big A? Little a. Over, what is the hypotenuse? Little b. What is the cos of A? Adjacent over hypotenuse. Little c over what? Little b. And we already know how to do tan, so we're not going to do that here, right? Does everybody understand? Because I am at A, there I am, my opposites and my adjacents are from my point of view. Everybody cool? So now over in this triangle, now I already know what A is. Over here, I want the sine of big C. What would it be? Here I am down at C. Little c over b. And what would the cos of C be? Little a over b. Does everybody see it? Depending on where we are, it changes the fractions. But please notice, all the numbers are the same. They're just in different spots. Is everybody good? If you can do tan, you can do sine and cos. It's exactly the same thing. Except now we get to look at the hypotenuse. Everybody cool? All right. Let's do a couple. We're only going to do 3 of them. Then I'm going to give you this next page of work. In this triangle now, do I have a theta? Is there an angle that I care about? What is it? Theta equals 12. Now, if theta is 12, this is my point of view, correct? What do I have? What is that side compared to me? So I have an opposite that is what? X. And what is this side? Hypotenuse. So I have an hypotenuse, which is what? 25. What uses O and H? Sine. So I need the sine of theta is O over H. The sine of what number? What's theta? 12 equals opposite. What's opposite? X over hypotenuse, which is what? 25. Numbers on the bottom. Multiply or divide? Multiply. 25 sine 12 equals X. So what button do I push instead of tan now? Sine. S-I-N. Sin. Whenever I say that, somebody always gets mad. Everybody good? So you don't change any of your method except instead of pushing tan, you push sin. Everybody good? So what's the answer? How much? 25 sine 12. 5.2. Is everybody able to do it? 5.2 equals X. Now let's go to the next one. Is there a theta that I'm concerned with? What is it? Theta equals 19. Once I've established that I am here in this position, what is the 40 compared to me? Adjacent equals 40. What is the X? Hypotenuse equals X. What uses A and H? Cosine. Cos theta equals A over H. Fill it in. What's the theta? 19. What's the A? 40. What's the H? X. Number on the top. Divide or multiply? Divide. 40 divided by cos 19 equals X. Do I change it from tan? Yes, in that I don't push tan. What do I push? Cos. 40 divided by cos 19. I don't have to close my bracket, but I want to be in the habit of closing my bracket. Because as you do more and more trig, you may go further and further on past one question. Everybody understand? So if you have a calculator that puts a bracket for you, get used to closing the bracket. Then what do I hit? Equals. And I get 42.3. And then I check. Does that make sense? It's longer than 40, and 19 isn't a very big angle, so it should be pretty close to 40. Was it? Yes. So we're right. Then we're going to do our very last one. Do I have a theta? No. I do not. So as soon as I see I don't have a theta, am I using sine cos tan or shift sine cos tan? Shift sine cos tan. But this establishes me in this corner. So what is this 13 compared to me? Adjacent. 13. And what is the 22? Hypotenuse 22. What uses A and H? Cos. Cos theta equals A over H. Cos of X equals A 13 over 22. So I got a shift cos now. Now listen to me carefully. If you do this question the way I'm about to do it, you're going to get a weird answer. All right? Some of you are getting this decimal first. You're going 13 divided by 22. And that's giving you a big long line of decimals, isn't it? And then you're rounding it off. Most of you would round that off to 0.6, wouldn't you? So most of you here would go shift cos of 0.6, correct? That is going to give you a very slightly wrong answer, because this is not 0.6, is it? So, if you're going to do that, if you're going to find the decimal first, you want to leave this on your calculator. So you would go shift cos. Now, does everybody see how right here on my calculator it says ANS? Most of your calculators have that feature. That stores the last answer that you have in your calculator. So my last answer, the last time I pushed equals, was this, right? So if I push answer, in there they're putting this whole number. Everybody cool? So now I push equals, and I get an answer of 53.7, which is 54 degrees. Everybody see? But look what happens if I do shift cos of 0.6, which is what happened when you rounded it. 53.13. Are they the same? No. One is 54, one is 53. Does everybody see? You want to use as many decimals as you can when you're actually doing the calculations. And here's why. If we were doing a really big project and we were off by half a degree, would it matter from me to Garlene if we were off by half a degree, do you think? Me to Garlene. It's not very far, is it? So if I'm off by half a degree, I'm probably still going to hit Garlene, right? What if I'm building a bridge that's 5 kilometers long? Every meter I move, I'm half a degree off, right? So if I'm half a degree off, I'm a little bit off. Now multiply that by 5,000. Does my bridge hit where it's supposed to? No. Does everybody understand? Be careful. Try not to round until when? The very, very end. Does everybody understand? If you can leave this on your calculator or get used to using that answer key, you're going to be better off. Okay? Is everybody cool? There's no tricks to trig. It's always theta and then an opposite or an adjacent or a hypotenuse. And then sine, cos, or tan. Always. There are no tricks. It is SOHCAHTOA. End of discussion. Are you all good? Great. Try the next page, which is page 60, whatever. Now, you have, actually, turn 59, 60, 61, and 62, and 63 is all trig practice. Now listen to me. Whose responsibility is homework? Yours, right? If you do all of page 62 and 63, whatever those textbook pages are, and you get them perfect, are you pretty darn good at trig? Do you need to bother doing the 3 puzzle sheets? No. Let's say you do the 3 puzzle sheets and you get all the jokes and it works out. It's English words and you're like, hey, those are funny. Not really. Myers gave to me. They're not funny. They're kind of stupid. They're making me go, ugh. But they're still making me kind of laugh. If you do those 3 puzzle sheets perfectly, how are you at trig? Pretty good. Do you need to spend a lot of time on the textbooks? No. Right? I am giving you enough practice that if you do all of it perfectly, you are guaranteed a very high A in my class. If you need that much practice, do that much practice. If you don't need that much practice, you needn't do that much practice. Do you understand? But do not come in here on Monday with 3 questions of trig done, because you will notice what is next on the outline. Don't come in here on Monday, oh yeah, I got it, having done 3 questions and then bombing the quiz. Understand? Do enough trig to be good at it. Who knows when you're good at it? You do. Not me. Got it? So you have 5 pages worth of practice there. Use as much of it as you want. I'm going to try marking for the next 15 minutes, and I'm going to hope I get your tests marked, and then we'll go over it before the end of the day. If I don't get them all marked, we'll go over it first thing Monday. Okay? Everybody good? We are probably going to go right to the bell, so I'm going to get this out of my way right now. Have a very good weekend. I felt this was a very productive first week of summer school. I think you guys are going to do just fine. Aight? Aight. Do something cool this weekend. Do not spend your whole weekend doing math. And remember, on Monday, I'm going to ask you what you did on your weekend. I'm 150 years old. I got kids, a dog, and I drive a minivan. You better be able to do something cooler than what I'm doing this weekend. You won't. But try. Don't let that get in the way.